All right, everybody. Welcome back to Scripting Crash Course for Creatives. This is class 4. My name is Kevin, and this series is all about teaching you just enough about scripting so that we can help you remove some of the tedious aspects of your workflow, as well as empower you to build some of your own tools to supplement your workflows and make things better. Today's class is all about control flow, but before we get into that, we're going to do a little bit of homework review with some of the functions that you all wrote. If you recall, our homework from last time was to write some functions that take arguments and do some stuff with that. So let's hop in and take a look at what people have done. Now, I went ahead and hopefully made the font a little bit bigger for this time. And there's a couple things about our homeworks that is worth covering. So first, we're just going to go through and just test a couple things. We'll start with our first student. They wrote a function to build a house, and as you can see, their arguments that they passed in were width, height, and depth. They do a bunch of stuff, and then all of those things get used. Those arguments are getting used down here in this scale command that changes the size of their overall house. So we're going to define it, and then they're going to create a house group, build the house, and if you recall, one of the requirements was to return a value. In this case, they are returning the house, and then they're going to print the house group. So let's just take this and run this. That's awesome. It actually totally worked, creates a house and runs it. Exactly what the assignment was. Now, in your own testing, something that you want to be able to do is you want to be able to run your function more than once. So let's do that here and run it again and see what we get. Second time, we get a second house. Okay, that's cool. That worked great. Now let's take this and move this off to the side and just change our values a little bit. Let's see if we can make something a little bit more square. So let's go 10, 10, and 9. We'll do the same thing again. Perfect. All right, so lots of good stuff in here. Basically, we took arguments, we used those arguments, we returned the value, and we're even printing out the name. So our house is incrementing each time. So that's great. Perfectly done. Good job with the assignment. Let's go ahead and take a look at our second house. So this house creates a plane cube and a pyramid, positions them, etc. Takes two arguments, a house height and width, and then it uses those to do a bunch of the math stuff. And then we call build house. Now, if we run this, let's just go ahead and run this. It builds a house, that's great. If we change this to 10, 10, and 10, let's actually move our house off to the side. If we change this to 10 and 10, you'll notice that it kind of works. It doesn't error. It creates a new house, not totally discernible as a house, but that's okay. Let's just try 100 and 100 just to see what happens. Looks pretty good. So bigger numbers work better with this particular house. One thing that is not happening here is we're not actually returning the name of the house or anything from the function. It didn't necessarily have to be the name. So we were missing that part of it, but that's okay. Otherwise, overall, this function successfully takes arguments, builds a house, and makes changes to it based on those variables that are passed in as arguments. So let's delete these all out. And we're able to run it multiple times. That's part of the goal. So let's go to our last one here. And what we're going to do is we're just going to give this a whirl. Works out great. We get house group 1. Now let's move this off to the side. And then let's take and change this to see what happens if we go with 5. Okay, this one we get an error. So the first time it works great, but let's just double check and see if it's just because it doesn't work or if we build it and it's the first one. Yep, so this is why I'm saying that it is a good idea to try to run your functions more than once. Let me just double check here. Okay, great. And the reason being is you may do something inside your function that doesn't work a second time. And so what you want to do is make sure and figure this out. So let's see if we can't do a quick little debug and help this student out a little bit. So we do have our argument and we are returning our house group. But what's happening is the second time I run this function, when we look at the error, it says more than one object matches name group 1. All right, let's take a look down in here. You'll see here, we're creating a house group called group 1 every time that we come into this function. And the problem with that is the first time we come in here, we create a group called group 1 and we put all of our stuff under it. The second time we create a house, we come in here, we create another group called group 1. But we already have a group 1. So what we really need to do is, it would be great if this group 1 auto incremented, or we were specific about the name of the house. So let's just change this real quick. And we can do it both ways. Neither one is wrong. But let's just change this to take another argument, and we're going to call it house name this time. And I want to show you the progression of this, the house name. We're going to call this house 1. All right, so let's take this and let's redefine our function and then run our code. And rather than using house group, wherever we have house group, let's use house name. So where are we using house group? To commands group, here it is. So we're going to use house name for our grouping down here. And then we don't even need this anymore. And I believe all we need to do is return house name. Now, returning the house name that we passed in doesn't make a ton of sense, but that's okay. It still is returning something. So let's try running that. House group is not defined. It looks like we missed it somewhere. We did. We missed it in the scale command. So let's go ahead and delete that and try one more time. Okay, no errors, and we have house 1. You'll notice it's called house 1. So let's move that off to the side and let's try to build house 2. So we'll copy this line of code and we'll build house 2. And I want to show you something. When we build house 2, we're going to set our scale to 5 this time. You'll notice what happened. All of a sudden our house jumped over here and we have one at the origin and we don't have a new group. Something got a little bit, something went wrong. So let's take a look at what went wrong. If we come into our code and we look at it, we have our houses, we have our cubes, we create the sizes, we create the depth. Here's our polycube, here's our move commands, etc. Here's our problem. When we do our group command, these names of these objects are hard coded. So what's happening is the first time we run our house, it creates prism 1, cube 2, etc., groups them, puts them under a node called house 1. The second time we run our code, this function, it tries to put prism 1, cube 2, and etc. underneath house 2 now. And then the new ones that got created, cube 3, 2, 4, and 2, are not even used at all. So what we really want to do is we want to capture each of these into a variable instead in order to make this function work a little bit better. So let's just do this. Let's call this my cube. And we're going to set it equal to the result of the polycube command. And I believe that is going to be this one. Oh, actually we have a bunch of cube. Yep, so that's that one. And then this is going to be, let's call this my walls. We'll set that equal to here. We have multiples of these, so this is going to be the cube 1. And then we need my prism. My prism, we'll set that to the value of the prism, and we can get rid of this prism. And then finally, we have a sphere, which is our doorknob. In this case, we'll do my doorknob and set that equal to this. And then we'll put, then we'll put this into we'll replace our polysphere. So now what's happening is, rather than grouping the same things every time we run this function, we are capturing the output of these commands into our variable, and then we're using the value of what's inside that variable to group instead, and then name it properly. So let's go ahead and grab this. We will run redefine our function. It builds house 1. That's great. Move it off to the side. And now let's build house. Oh, we didn't get that very far off the side. Now let's build house 2. Great. So now we have house 2. You'll notice that we now have 2 houses, different sizes. Everything's grouped nicely. Everything's named nicely. And we're ready to go. Overall, first shot at this, the assignment worked. All I'm offering is that part of your thinking when you create functions is you want to be able to run them multiple times. So in your testing, you want to try to run your function multiple times to see what happens to make sure it's working as you expect. Okay, so let's hop a little bit into what we're going to be doing today. Today, as I mentioned, is about control flow. Now, what I mean by control flow, we've done a lot of really cool stuff with variables and functions and things like that. That is making our code more reusable, more efficient, and a lot more logical as well. And we can now do a lot of different things. However, it would be really cool if we could make decisions in our code. And what I mean by that is maybe depending on the street address, you want to build a big house. So for example, let's say that every odd number house in your neighborhood you want to be big, and every even number house you want to be small. So the math or the logic there is, if the street address is odd, build a big house. If the street address is even, build a small house. Okay. Or you could say, if it is night, go to sleep. If it is day, wake up. Basically, the control flow specifically that I'm talking about is called an if statement. And the way it works is, if something is true, do some stuff. So let's look at a simple example of this. Make a new Python tab. And all I'm going to do is I'm going to define two variables, a equals b, not a equals b. Actually, we're going to go back to our other tab because it is easier to read. All right. So what we'll do here is we're going to define two variables. Let's say a equals 4 and b equals 5. Now, what we said was the way an if statement works is if something is true, do some stuff. And it's almost written exactly like that. So let's go back to some basic math and let's just try. I'll show you how we write it as we go. If, just like it sounds, it highlights green for us. If A is greater than B, no, let's do this. If A is greater than 3, print A is bigger. Okay. And then what we can do here in our second one is if B is less than 10, print B is less than 10. Okay, so the general format of an if statement is if something, a condition to check, if something is true, and then you have your colon, and just like your function, do all the stuff that's indented. Now, in order to run this, let's just define A and B. And if A is greater than 3, print A is bigger. Is A bigger than 3? Hopefully you're looking at it and saying A is 4, that's greater than 3. So is that true? Yes, that's true. So should we print A is bigger? Yes, we should. So let's run it. Cool. Now let's do the same thing, except now let's check a different number. We'll stick with A for a second. If A is greater than 5, print A is bigger. So right now, when we start, let's just to remind ourselves, we know that A is 4. Is A greater than 3? True or false? True. So we print bigger. Is A greater than 5? No, that's not true. So we're not going to print A is bigger. If we redefine A to be 14, is A bigger than B? So is 14 greater? I'm sorry, not bigger than B. Is A greater than 3? Is 14 greater than 3? Yes, that's true. That's true. So we're going to do the stuff inside. So let's run it. A is bigger. If A is greater than 5, print A is bigger. Is 14 greater than 5? Yes, it is. A is bigger now because we redefined A to be 14. Now, it works also with less than signs as well. So in this case, B is 5. Is B less than 10? 5 is less than 10. That is true. So we will print B is less than 10. All right. Now, there are multiple ways to determine or define or test for something as being true or false. So for example, we can simply say true and false. So let's define two new variables. Let's say C is equal to true, and let's say D is equal to false. Now what we can do is we can say if C, print C is true. And copy all of this, and I can say if D is true. All right, so let's define our variables. C is true, D is false. Now, is C true? Hopefully you're saying yes. C is true, so are we going to print C is true? Yes, we should, so let's test that. It prints out C is true. Is D true? No, we've defined it specifically as false. So D is not true. Should this print? The answer is no, because D is not true, so it's not going to print. So it doesn't actually print anything. All right, now so there's different ways of testing for true. Is a number greater than a number? Is the actual value true itself? I'm going to give you another one. Let's create a list, okay? And this list is going to be my list. And we're going to set it to a bunch of letters. Let's go I said letters. A, B, C, D, and we'll do E as well. Okay? So I've defined this list. And there is a way in Python to check if something is in a list. So if B is in my list, print you have it. Okay, so let's run this. I'll move this up so we can see it a little bit better. So here's our list. We'll define it. It's just A, B, C, D, E. Now, is B in my list? Yeah, it's the second option in here. So if we check to see if B is in my list and that is true, which it is, we should print you have it. All right, well, let's check another one. Is F in the list? Nope, it's not in the list. So are we going to print you have it? No, we're not, because F is not in the list. So it's not true. And so we don't do anything. We don't do all of this stuff. Now, that's just the quick intro to how the formatting of it. If something true, do some stuff. Now, there's more that we can do. So what we could do is there's a couple other parts to if statements. And in this particular case, what we can do is we can do an else. So if something is true, do some stuff. Otherwise, do something else. So the way that works is just like it sounds. We just type else. And what we'll do here is we'll print you do not have it. All right, so what's going to happen is this is going to come through here and it's going to check to see if F is in the list. Is F in the list? No, it's not. That is false. So else, basically, so if this is true, which it's not, then what we're going to do is we're going to print instead. We're going to print you do not have it. So now when we run all of this together, you'll notice it says you do not have it. So you can say if, do some stuff, otherwise, and that's what the else is, do a bunch of other stuff. Okay, now let's add one more to this. We can do an elif. Okay, let's do B in my list. print B is in the list. All right, so now what's going to happen, let me just double check that this is right. Yes, okay, cool. So if F is in my list, is that true? No, it's not. Else, this is what elif means. Else if B is in my list, print do some stuff. Otherwise, or finally, else, print you do not have it. So if F is in my list, that's false, so we're not going to do that. Else if B is in my list, is B in my list? It is, so we're going to print B is in the list. And then it just finishes. That's it. That's the end of the whole statement. So when we run all 3 lines of this together, it goes through and it prints out B is in my list. If we change B to BG, now what's going to happen is F in my list? That's false. So it doesn't do that one. Is G in my list? Nope, that's false. So it doesn't do that one. So then what it does is it comes to the end and says you don't have it. So if we run this section of code now, it will print you do not have it. So all an if statement does is check if something is true, and if it is, it does some stuff, and if it isn't, depending on whether or not you've defined the else or not, it will finish. Okay, so now that we've done that, let's take a look at one more thing. Now, I'm going to simplify this back down to, I don't use the elif a whole lot, but you can, and it's just good to know that it's there just in case, because that is a question that comes up. So we're going to simplify this back down to if F is in my list, else print you do not have it. And there's another way that we can write this exact same thing. What we can do is we can take this, I'm going to rewrite this. I'm going to say if F is in my list, print you have it. Now there's the idea of not true. And I want to show this to you. I know this might hurt your brain a little bit, but I think it's good to know just in case you see it. So what we can do is right now we say if, and we're checking to see if all of this is true. What we can do is we can check if it's not true as well. So we can simply type in here not. Now what this is going to do is it's going to come in here and say, is F in my list? It's going to say that's false. And then what's the opposite of false? True. So not, that's what this not does. It says, give me the opposite of whatever this is. So if F is false, the opposite is true. So in this case, this reads as if not F in my list, which ends up being true because F is not in the list, we're going to print it. So let's run these 2 lines of code. Is F in my list? You have it. If not F in my list, oh, I need to change my print here though. Let's do that. If it's not in the list, we can print you do not have it. So you do not have it. So these two sections, if not in my list, and or if F in my list and if not in my list, is the almost the exact same thing in a way as running this section. We will, in both cases, we will print you do not have it. And the point here is to have an understanding of what this not does. All it does is it says, give me the opposite of whatever is happening to the right. So F is in my list. So for example, if we were to change this to A, normally when we run this, is A in my list, this will print you have it. But right now, when it checks is A in the list, that's true. But what's the opposite of true? False. So if that's the case, it's not going to print the second thing. It just runs past it. Okay, so that's a quick little introduction to the idea of not in your list. Let's take a look at other things that we wanted to go over today with if statements. We have in my list. We talked about the else statements. All right, so what that does is that puts us in a point, in a good point of understanding one of our simplest and first control flow structures, the if statement. We're going to take this and we're going to use this a little bit to update some of our house code to do something with it. And what we can do with that is we can go through and we could, for example, I remember what we were doing. Let's do the odd even thing. and make big houses for odd and even houses, or small houses for even, for example. All right, so I'm going to create a list of, I'm going to create a house list. And these are going to be the numbers, the addresses for the house. And I'm going to go with just simple integers, 1, 2, 3, 4, 5, 6. Now there's another lesson in here too that is about some of the math functions in Python, so stay with me here. All right, so we have our house list. Let's print the house list. And it prints out 1, 2, 3, 4, 5, 6. Great. Now, remember I said I wanted to make a small house or a big house depending on whether the house number was odd or even. Okay, to do that, let's do a couple things. What we can do is let's get a variable called house to make. And we're going to set it equal to house list 0. Now, house to make right now is going to be, and if you remember when we're working with lists, what is the index, the address of the bucket? They go like this: 0, 1, 2, 3, 4, 5. Now just for ease, I'm going to make this, I'm going to make these 10, 11, 12, 13, 14, and 15. Just because it makes it easier not to confuse our index in our list index with our actual values themselves. Okay, so the first house in our list is at index what? 0. The address number for the first house in our list is 10. What we want to know is 10 odd or even. And depending on whether or not it's odd or even, we're going to determine whether or not we build a big house or a small house. So how do we test for odd or even? We could divide by 2. If we divide by 2 and there's a remainder, that would tell us that it's odd. If we divide by 2 and there is no remainder, that means it's even. Now there's a I don't know if it's a programming or an old math thing, but there is a function that you can use called it's not a function, it's like a sign, like divide, multiply, subtract. There's something called mod, and what mod does is it returns the remainder. So let's just do this. Let's print 4 mod 2. Mod is represented by the percent sign, and you'll see here if I print 4 mod 2, it returns 0, because 4 divided by 2 is 2 with nothing left over. 4 divided by 1 prints 0, because 4 divided by 1 is 4 with 0 left over. If we print 4 mod 3, what is 4 divided by 3? Basically, this percent sign is divide by a number and tell me what's left over. If we divide 4 by 3, 3 goes into 4 one time and there's 1 left over. Okay, so that is how we can determine how this works. So if we take anything and mod it by 2, we should know whether it's odd or even. So let's take a number, for example, like 3, and mod it, divide by 2. 3 has 1 left over. Let's do 7. If we take 7 and we mod by 3, so if we take 7 divided by 2, that's going to be 3 with 1 left over. So it's going to return 1 left over. Now, remember how I told you there's different ways to evaluate true or false? Okay, 0 is false. Anything other than 0 in Python is true. So 1, 2, 3, 4, 5, 6, those are all true because it has value. So we can use this to determine and make decisions as to what kind of house we're going to build. So for example, this is going to be a house number. I'm gonna change this house to make to be the house number. It's gonna be easier to remember, okay? And what we're going to do is we're going to say if house number mod 3 or mod 2, I'm sorry, we're going to build a house. And the house that we're going to build is going to be let's do let's just try this. We'll just try house and see what happens. And we're going to make even numbers big. Let's go with 3 or 4. All right, and if otherwise, what we could do here is else we were going to build a small house. Let's make it 1. Now I haven't actually tried to run our code with just the word house in it. I think it will work because I think it will automatically increment our stuff. So let's just go ahead and try that real quick just to make sure. If all we do is run this, yeah, it's creating a bunch of different houses incrementing. So we know that works great. So that's not going to be a problem. So now we define our house list. The house number that we're going to check and build is going to be the house that is in the list address 0, which in this case is 10. So is 10 divided by 2 or mod 2, does it have a remainder? And this is the easiest way to say this is it even? If it's even, we're going to build a big house. Otherwise, we're going to build a small house. So let's just run this code. We built a small house. I think it's small. I'm going to have to take a look here in a second. So just for sanity's sake, house number is, let's print our house number when we come in here. It's 10. And what is house number? Mod 2. 0. So if it's 0, it built the house 1. So now let's do this again and let's use the second house in our list, which is at index 1. And in this case, the house address is 11. The house number is 11. Let's see what happens when we run this. Actually, let's move our first house to the side a little bit. Okay. And now when we run this, you'll notice we get a big house. We do have a problem in our code because it looks like it's still doing the thing where it updates the house instead. So what we can do is when we create this group, rather than giving it the name house name, what we can do is we could just capture this. Let's just change our code. We're not going to use the name at all. We're just going to use house name is equal to that. And then we're going to return house name. This should still work. Now the difference is it's going to change the name of our house. It's going to be just group. Oops. It's going to be just group instead. And what we pass in shouldn't matter. Yeah, so there's group 1, group 2, etc. Great. Okay, so let's go back and run this again now that our base code is okay. Hopefully you're using your house code for this. Okay, now let's go back to the first house. So let's build the first house. We'll run everything. So we're printing, so we're building a house number 10. 10 mod 2, which is it even, is 0, so that's false, so it builds a house. Now let's move this off to the side. Okay, and then let's take and do our second house in the list. And it builds a big one. So we now have the ability, based on whether the house number is odd or even, to build a small or a big house. Now, you can make decisions on anything. You could say, like I said, if it's daytime, wake up. If it's nighttime, go to sleep. If you're in a specific neighborhood, you want to build a different kind of house. You can do entire groupings of things like that. The overall point, though, is if something is true, do some stuff. Now, I went through this with the house just as an example of a way to do it because you're going to have some homework to do. But we're actually going to take this one more step just to reinforce what we're doing with these if statements, and we're going to update our tracking object functions. So let's see if I can make this bigger so you can read it. Nope. So what I'm going to do is I'm just going to copy this into our other tab. It'll be easier. All right. In our previous class, we defined a function, and we kind of started to create the start of like an animation tracking node. So what I need is an object that I can track. So let's make something that will be easy to tell the difference between. So let's just do cylinder. Okay, and what we're going to do is we're going to set a couple keyframes on the cylinder. We'll set a keyframe here, and then we'll come forward in time, set a keyframe here, come forward in time, and set a keyframe here. So our cylinder now moves through time and space. Okay? Now what we were doing before was we basically said, we kind of said, and this is another control flow thing we had talked about last time. We're not going to worry about it yet. We're going to be talking about for loops in the next class. But just for ease of use, what we said was this basically goes and increments I, right? It basically goes through each frame. And we create a track object for our item. And in this case, what we want is our object to track is going to be the cylinder. And then we set our current time. So if we run this as is, just like when we finished last class with our cylinder, it creates a locator at each frame. Now, we want to adjust this. We want to make this more useful. So how are we going to do that? We're going to use if statement. And what we're going to do is, it would be really cool if we could look at the tracking points and know if it's a keyframe or not. It's perfect. We just said the words out loud. If it's a keyframe or not. So instead of tracking the locator and we're going to create a command, let's do this with a sphere. So we're going to do sphere instead, and we're going to call this track. We can keep it called track locator. This is going to be the exact same code. Now the difference is we're going to create a sphere. Now I'm also going to make our cylinder a lot bigger so that we can, oh, actually the scale is getting keyed there. I'm also going to make the distance a little bit more so it travels further. Okay, and then let me, in our channel box, just delete the keyframes on scale so I can make this bigger so it's easier to distinguish between our keyframes. Okay, so let's take all of our spheres and delete it. And actually, I can keep them as NURB spheres, that's fine. You probably may want to use a polysphere instead. But anyways, so we've changed this to spheres. Then what we want to do is we want to use our if statement. And we want to do it based on keyframe. So the first thing we need to do is we need to get a list of the current keyframes on the object to track. So let's just do that. Let's say keyframes is equal to, there's a command in this, there's a my command, commands.keyframe, and we can do object to track, and we can query equals true. Okay, and just to test this out, just so you can see how this works, if we, nope, I didn't even copy the right thing. If we just run this command by itself with the poly cylinder, you'll see that it returns a list of numbers, 1, 25, 53, etc. Now it's returning a bunch of lists of numbers because there's keys on scale, rotate, etc. But that's fine. So we have our keyframes for our poly cylinder. This is the command that we want to use. We're going to store these keyframes in a variable. Then what we're going to do is we're going to say, if the current frame is in the list of keyframes, then this is a keyed frame. We want to draw something different. So to do that, we need the current frame. How do we get the current frame? So the current frame is equal to commands.current time query equals true. If we run this, just this, it's going to print out the current time of 25. So now we have our keyframes and we have the current frame. So all we want to do is we have our track locator, and what we're going to do is if current frame is in the keyframes, we're going to do a bunch of stuff. Now, there's two different ways that we could approach this based on what we learned earlier. We could say, if the current frame is in the keyframes, create a sphere, else we're going to copy all of this code. We'll do I believe it's polycube. Polycube. Gotta spell it right. Polycube. So what's gonna happen is it's going to come in here. If the current frame is in keyframes, else make a cube. So it's going to either create a sphere or a cube depending on which one it is. So let's just run this and see what happens. Nice. We're already almost there. Look at that. So our code is using a simple if statement to do something really powerful for us. And now visually, we can see whether or not a frame is a keyframe or not, just by simply looking at the graphic that came back. If we take all of these and we delete them, I missed one. Okay. We can write this if statement a different way. So we're just going to write this if statement a couple different ways. We could also say if the current keyframe is not in the keyframes instead of using the else. If not current keyframe in keyframes. This will do the exact same thing. Personally, in this case, I think it's more logical and easier to use else because tracking these not conditions can be a little bit of a mind game sometimes, but it's worth knowing that you can do this. So that's another way to do this. Now we're going to go back and we are going to make a couple of changes to our code to make it more efficient. We did it this way because it was easier to visualize, but there's something that I want you to note. There's a lot of repeated code in here. Everything about this track locator, this point constraints, there's a lot of repeated, all this point constraint stuff and everything is happening inside these if statements because it was logical and easier for you, hopefully for you to follow. If it's a keyframe, make a sphere, do the stuff. Otherwise, make a cube, do the stuff. Well, all the extras we can move out. So let's just do this. We're going to take all of this point constraint stuff and we're basically going to unindent it. So now we have an if else, but this is not going to work because track locator is not defined ahead of time. We need to define it ahead of time. So let's just define, let's take and define track locator and set it equal to nothing right now. And what this is going to do is this is going to come in here. It's going to define a variable called track locator, and it's going to set its value to be an empty string, nothing, because it's waiting. Then what we're going to do is if the current frame is a keyframe, we're going to store a sphere inside the variable track locator. Otherwise, we're going to put a cube in there. And then after we're done with the if statement, we're going to point constraint, orient constraint, and do all the things. Let's test this. There we go. Same thing, same result, a little bit more efficient code, all using our if statement. Now, we can actually take this even a step further. No, let's not take it a step further. Let's just leave it at that. That is a super clean way to kind of like create a quick little tracking script for us. Now, again, the overall point here is if statements. If some condition is true, do some stuff. Else if, or if not, do other thing. That's how it works. Pretty straightforward. Now, this tool that we're potentially building here and that you're seeing working, let's take a look at a version of this that is a little bit more flushed out so you can see the kind of things that we can do and get to. So to do that, I'm just going to launch this real quick and show you when we use this. This is basically a flushed out version of a tracking tool, a little more flushed out. And what we can do is we can click a button, and what that's going to do is it's going to create markers. Now the markers in this case, you'll notice are axes that point in different directions. I'm going to switch this. This tool allows you to change what the types of markers are. And so in this case, I'm going to change these to spheres, and I'm going to create the markers for this. You'll see that I create three green spheres. I'm creating 3 green spheres, 1 for each keyframe. This tool also allows you to, I'm going to change the size of these real quick, cut them in half. You can also do keyframes or all frames. So if we come in here and we create markers for selection now, it does exactly what our tool is doing. And it creates a bunch of markers for each of these frames. Now this is a little bit of a wild thing. They're pretty darn big. So let's make them smaller and not quite so many of them. Let's go 0.1 and let's create markers. Okay, so now we can actually see what we're looking at. Green spheres are keyframe. And what's more is if we move one of these spheres, we can actually align and change our animation to that. So if I click a button, what I can do is I can now snap my cylinder to that frame. And so if I create the markers now, you'll notice that now it goes higher. And all I did was move one of the spheres. If I move this sphere, for example, I can align node, and this will actually add a keyframe. So if we create the marker, if I have auto key on, I think I do. Delete all markers. Yes. Create the markers. So here we go. My machine is chugging right now, but you'll notice that our arc changes. So all of the stuff that we're doing, we're almost there. We are literally creating different objects based on a couple logic. Now, you know, we talked about if statements, but don't forget functions are also a way of controlling logic as well, because you can group things and everything like that. So that kind of wraps up if statements. We're going to be talking about more control flow structures in our future classes. So let's take a look at wrapping this up. Let's do a quick little recap from today. We checked out our homework from the previous class, and we learned a little bit about how we should consider or think about debugging some of our own functions, making sure we run them multiple times and things like that. We also introduced our first, and I would say probably one of our most simple control flow structures, the if statement. The cool thing about the if statement is it is written exactly the way it sounds. If something is true, indent, do whatever is intended. Now, with your newfound knowledge and understanding of if statements and control flow, we're going to do something a little bit we're building on the complexity of the homework. So tonight's homework, let me just share the sticky note. Tonight's homework is to write 3 functions. One function is going to create a sphere or a cube, and it's going to return the name of the sphere or cube that was created, and you need to use an if statement. Second function is going to position any object I tell it to at a space or spot in your scene. It takes the name of the object to move or position, as well as where to put it, and it does its work. The last function is kind of like our main or run function, and this uses the other 2 function to create at least 1 sphere and 1 cube and position them somewhere in your Maya scene. So that's your homework for this week. As always, all feedback is welcome. If you're new to scripting and this truly is a scripting crash course for you, let us know how this class went. If you're a guru, you're an expert, an ace in Python, and there are things that you think we could explain better or do differently, also let us know. If there's, depending on what the feedback is, if the need is there, we're happy to re-record these lessons, make them more clear in certain areas, etc. Also, let us know what you think about this content. If you want us to keep making tutorials and training like this one, let us know so that we can make sure that we're creating the videos and spending the time where you all find it the most valuable. And finally, help us support the channel. If you like what we're doing here, spread the word, support the channel in the ways that you know best so that we can keep making this kind of content. I hope you all have a good one. We'll see you in the next scripting crash course for creatives class, or hop in one of our upcoming Q&As and AMAs with any of your questions. Hope to see you soon. Take it easy.